Hi, good morning. I'm Tom Boutell. I'm with Punk Avenue, a design and build firm in South Philly. I've said the words object-oriented so many times in the last 2 days that it's the only sentence I can utter at this point. I'm going to talk to you about object-oriented functional programming, which is a fun thing to say, a fun thing to throw around, because when I say it, people are like, really? Like, wait, you can do one of those things, you can do the other one. Can you do both of those things? Is that allowed? Doesn't that like come apart? Doesn't the car fall apart and explode? Something. So I'm going to explore what happens when you try to put those approaches together. And an approach that we've taken at Punk Avenue in building Apostrophe, our open source content management system. It's something that's frequently rediscovered, and it has its pros, and it definitely has its cons as well. And in order to kind of legitimize that, because some people kind of think of it as almost a dirty technique, I'm going to explore some of the performance issues and give you a few specific numbers, just to give you a sense of what the real trade-offs are, just to maybe remove some of the stigma that sometimes surrounds the idea. First, I want to define my terms a little bit. When I say object-oriented, I don't specifically mean prototypal inheritance, or class-based. Well, I do mean class-based inheritance as a general idea, but a particular implementation of it. And I don't mean private and protected and public, all that jazz. What I mean is the joy of types. I mean the ability to create types of objects and associate behavior and data with them and work in a fluid way with types of information. And I mean specifically the ability to effectively reuse code, the ability to effectively extend code, where you can both modify, where you can say, okay, so we're going to have, let's say we're going to have people in this application. And in this particular application, I'm going to change the behavior of people a little. And also the ability to subclass and say, all right, well, we're going to have users, and we're going to have speakers, and we're going to have administrators, and to inherit behavior. And finally, really intuition, the ability to work naturally with ideas like, to take the hoariest example in the book, which I am going to run right into the ground, that all collies are dogs, but not all dogs are collies, to talk about types in a way that just makes intuitive sense. On the functional side, I have to be careful here to define my terms. If I really wanted to get into functional programming and the theory of that, I'd have to go back for my doctorate, and it would still take me all day to explain, not to get my doctorate. So things I don't mean a lot of academic theory. And although this is a useful thing that's worth talking about, I don't mean immutable types. What I mean is the joy of functions. I mean the ability to compose functions, to use, for instance, iterator functions that will work with, say, any sorting algorithm, things of that kind, in a really fluid way. The ability to create larger abstractions out of functions, and the ability to make fewer mistakes as a result of the fact that you are not constantly bogged down in minutiae that we remember. I mean, how many people here have ever programmed in C or C++? It pumps up the numbers a little. Or even Java, really. People spend a lot of time writing for loops that just iterate over things and making mistakes doing that. That's insane. No one should do that. That's one of the fundamental wins of functional programming, except for certain patterns in JavaScript that almost take it away from you. And finally, I mean that functions allow us to deal with asynchronous situations in a somewhat rational way. How many people here have worked with Node.js in the past? A decent number, okay. So you've dealt with callbacks a lot, and you've probably worked with a variety of systems that try to sanitize and civilize that. How many people have worked with promises? Sure. And promises are wonderful, actually, but interestingly, they don't solve quite the same set of problems. So there's overlap between what I'll talk about here and what promises can give you. And I just want to acknowledge that I'm going to be unfair. Because I'm talking about different approaches to object-oriented programming when, in almost all programming languages, they actually do have the same kind of warts that I'm talking about when it comes to asynchronous development and to certain kinds of functional development. But the reason why I don't think this is truly unfair is because JavaScript is sort of unique in that almost no one uses threads in JavaScript. Whereas in Java, or in a sense in PHP, you always get a thread of execution for dealing with the thing. Like, here's a request, deal with the whole thing, do things in order, and you're done. And you don't have to worry about some of the situations where having asynchronous programming be difficult is really ugly in JavaScript, where it's more important to you. And finally, I want to define what I mean by joy a little bit. When I talk about the joy of functions or the joy of types, I'm talking about fewer WTFs per minute. Really, I think the most important measure of code quality, and I want to qualify that by saying that I don't think there are no other important measures. Performance obviously is relevant, because if your code takes all day to run, it's not fast enough. At the same time, I don't worship performance as a god in quite the same way that I worship not staring at my code for 6 hours to figure out why it doesn't work as a god. I find that to be just a more rewarding thing to believe in. But of course, you have to take performance seriously, and you have to ask questions not like necessarily, is this the absolute fastest way to do this? Because the answer to that question is no, it's not written in C++. But you do have to ask, is this within like a reasonable, like a constant factor of being the fastest way to do this? And if so, it's probably an okay thing to be doing unless you're a game developer, in which case you should be working in C++. So that being said, I'm going to start out by looking at some interesting object-oriented programming examples. And I will start out very simple indeed, just using, and I'm going to start out using classic prototypal JavaScript inheritance in the way that people traditionally, kind of built classes out of it. And I'll do that for reasons that you'll see as I go on. It makes sense as the starting point because it's ultimately what we still get, even with the newest syntax. So the most basic object-oriented program I can really do in JavaScript is simply to create one type of object, a dog, to have a nice constructor that captures the name of the dog, and to have a method that allows that dog to bark. It's about as simple as these things can get. And it's no surprise that this works. And yet, if you're not wildly familiar with prototypes, it is strange to look at. If you come from a background of PHP or Java or C++, almost any other object-oriented language, you're used to classes. And to see this business where we're instead attaching a method to a prototype object that is the object from which all new dogs inherit their behavior, it's not immediately intuitive. It has some advantages, but it is a little strange. And we used to argue a lot about this in JavaScript development, but with the advent of ES6 classes, I would say that we're arguing about it a lot less. I think that we've agreed on a way of approaching it that is fairly constant. But it does relate to some of the difficulties that I'll talk about as I go on. So to take a slightly more interesting example, I'm going to extend my dog type here. I'm going to create a Kali type. So I have a specific type of dog. And I have a method, speak, which is used simply to print a message with the dog's name preceding it. I have another method, bark, which allows the dog to bark, simple enough. Now I'm going to extend dog, and I'm going to create a subclass called Kali, loosely speaking. My constructor for Kali has to call the constructor for dog explicitly. I have to use the call keyword to invoke it so that I can say, I want that constructor to run with the same object as my object. I'm going to pass this into it using this special syntax. And then I'm going to pass on my arguments to that. Finally, I can speak and announce myself as a Kali, because I guess Kalis are loudmouths and like to announce themselves when they walk into the room. It would seem like that should be enough, but it's not enough. I have to do a lot more because I have to set up the prototype chain. I have to set things up so that all of the properties of Kali will inherit from the properties of a dog. And I trust myself sufficiently little with this that I blatantly wrote a very long comment, as the last speaker was saying, he's usually a bad signing code, to make sure that I didn't misspeak about what the prototype chain is actually doing. But in order to have Kalis have their own object that every Kali inherits any property from that isn't explicitly defined for that particular Kali, we need to create a dog object without running the dog constructor. We don't want to do that yet. We just want to have an object that they can all inherit from. This is something that came along in ES5, this ability to call object.create and say, I want it to inherit from the same prototype object, but I'm not actually using the new keyword, so please don't run the constructor. If you actually needed this code to run in something earlier than IE9, it would be uglier than this. Fortunately, none of us hopefully need to do that today. One last touch, which everyone does, and I have difficulty sometimes remembering the justification for, is just to make the constructor method available on the prototype itself. The only explanation I've found for this is, well, it isn't necessary, but it maintains certain useful invariants. So I guess that does it for them. I don't know. Finally, I can override the bark method for collies. And if I just wanted to override it to call, to just completely replace the implementation, I could just say collie.prototype.bark equals function, and just go ahead and call this.speak or what have you. But because I want to also have the behavior of bark for all other dogs, I have to explicitly call the parent class version of it. And finally, I can create a collie, and my collie can bark. So moving into where we really, prior to that, we were frustrated with the complexity of it, but we were also aware, well, in various JavaScript libraries, it's not as bad as all that. I mean, just about all of them going back to Backbone have conveniences to make some of that go away, although you need a surprising amount of code in a library to do a good job of it. Where things got interesting is because we do a lot, and I mean a lot, of asynchronous and functional development. And in asynchronous development, you need to be able to pass functions as callbacks to other functions and say, hey, when the time comes, please do something. When you're finished, please let me know that you did something, and so on. And so the most natural thing in the world would be to say, okay, I'm going to write a bark after 1 second method that will wait a second and then bark. But this is JavaScript, so I can't, there's no sleep. I can't say sleep for 1,000 milliseconds. I can't block the thread of execution. That's just not a thing. So instead, I'm going to use set timeout, which we all recognize, to say, okay, in 1 second, run this function. Except it doesn't work. It doesn't work because this is not lexically scoped. In English, it doesn't work because this is very silly. And it has been very silly since the very first version of JavaScript. And because there are provisions in JavaScript to work around this, and I will show you those, people get a little upset when I say that this is very silly, because they're really good at those workarounds. And it's great that you are good at them. I would just encourage you to set yourself free from the sense that your self-worth is in any way tied to whether it was a smart idea in the first place for this to be dynamically scoped. It's great that you can work around that. I'm impressed. I can work around some really scary stuff in a lot of programming languages. So to make this work, and just for fun, I mean, I'll run this one. So it waits a second, and then it tries to call this.bark, and it doesn't work. In Node, the this object at this point is the timer itself. In the browser, it'll be something else. It'll probably be the window. But the point is that it's not what you wanted. So let's look at how we can address that. Nope. There we go. Okay, so I wanted to show, I think first I'll show you the successful version of that. Let's say that we want to solve this problem and we know about closures. How many people here use closures regularly in their code? A closure is a way of capturing the scope of a function simply by, if I am in a function which defines some variables, and I return another function, if I pass another function off to some other code, all those variables in the scope of my method, my function, still exist. And they can be accessed by that function that I've passed off. You actually have to be careful with this. There are times when you have to make sure that you did things like clearing a time, interval timer or what have you, so that other code doesn't assume it can still use that. But in this case, I'm going to solve this problem by taking the advantage of the fact that, well, this is not lexically scoped, variables are. So I'm going to capture this in that. And a lot of you have probably seen this wording. A lot of people say var that equals this in this situation. And by creating this closure, what I'm doing is I'm ensuring that inside this timeout function, I can call that.bark instead of this.bark, and that will work because I've captured that variable. And that's going to have its same value even though this is now the timer object. So why not just do that everywhere? Well, because this is one method. And when you're doing a lot of asynchronous development, you don't have one method. You may have dozens or hundreds of methods. And every single time you do that, you need to remember the strange little bit of syntax. That is a recipe for things not working. That is a recipe for mistakes being made. There is another approach that I should jump on, which is to solve that same problem with the bind method. All functions in JavaScript have a bind method, and what that bind method does is it allows you to say, I want to create a new function which, when I invoke it, it'll assume that it's connected to this object. It's connected to this as of the time my method originally ran. So the function that actually gets invoked after 1 second by setTimeout is going to be this version that's cleaned up to be already associated with the right object. And this works too. It absolutely does. 2 things about it. It's still a lot for you to be thinking about. I want to just set a timeout and have it call a function when the time comes and have the right thing happen. But instead, I'm thinking about binding stuff. And the second thing is that actually it's slow, which is surprising. But it's true that the closure approach is actually faster. And I'll show you some metrics on that later, which you can also find elsewhere on the web. So I wanted, though, to touch on one simpler case that doesn't involve async development, because I know that sometimes when we write asynchronous code, we feel like, well, async is hard. Duh, it's hard. It's supposed to be hard. It's going to be complicated. It's not going to be easy to do. But it's got this amazing performance because Node is fast, man. And like, this is what I get for not being a PHP developer. This is my big win. So I'm willing to pay this price and suffer. And mind you, I write a lot of PHP. So I just wanted to show you an even simpler example that doesn't involve any async, but where we still can't do functional programming in a sensible way. All I want, the simple thing which is my goal, is a method that will allow one of the dogs to sniff all of its friends. Pass it an array of friends, it'll sniff all of its friends. It's what dogs do. We all get it. So I'm passing in an array. I'm passing in an array of friends. And I want to sniff each of the friends. So I could do this with a for loop, and that would work. But we were just talking about how for loops are a silly thing to be writing when we could be doing functional development. And we could be taking advantage of methods like for each, which newer JavaScript gives us on every array, or lodash, _.each, or any number of other things. And I'm going to pass that a function. And with that function, I'm just going to call this.sniff on that particular dog. And there's no async here, there's no wait a second, there's no any of that, and it still doesn't work. It doesn't work because, again, this is now the array. That's terrible. I mean, that's not a thing that I should ever have to think about. What I've lost is I've lost this convenience that something like for each is meant to give me in exchange for being able to do object-oriented programming, and this isn't a trade-off that anybody should have to make. Peeked at that one. I just wanted to acknowledge that promises, well, they are very cool and solve a lot of problems. And I apologize because this particular example is a bit contrived of using a promise, for a 1 second timeout, because I don't actually care. What promises are really good at is letting me do something after that happens. So I've added a little bit of code. I've added a then function here so I can acknowledge, OK, after I did my 1 second thing and I barked, then I'm aware that that happened in a relatively elegant way. But it doesn't address this problem. That's not what it's meant to do. It's not its job. So if you're mixing object-oriented styles with functional programming and/or promises, it's still a relevant issue in your life. Now, when we get into ES6, we can build, the good news is we can build our dog class in a way that's familiar, involves less code, And it's just more pleasant to work with. We're not thinking consciously about the prototype chain. We're just creating a dog class. We give it a constructor method. We kept your name in this. We go right ahead and bark. It's pretty straightforward. And when we want to subclass, that also can be, well, moderately elegant in ES6, because the original ES6 class specification did not have a super keyword. It didn't have a convenient way to call the parent class's version of a particular method. So instead of being able to just say super.bark, we had to still dig back into that prototype chain. And you're probably thinking, well, now wait, where did this come from? I don't see any prototype anywhere else. And the reason for that is that ES6 classes are just syntactic sugar, which means they are compiled down to plain vanilla prototype-based JavaScript. It's turtles all the way down. It's all the same thing at the end of the day. So when we want to solve the same problems that I was talking about earlier, we are almost stuck. We are almost stuck with using that and using bind and so on, but not quite. We do have a piece of syntax that does, I want to acknowledge, clean that up significantly. We have the ES6 arrow function as at least one of the solutions that ES6 gives us to make this part of our lives a little bit better. What an arrow function does is it's very simple syntactic sugar for writing a function in a less verbose way. This is equivalent to writing function dog, this.sniff dog, but followed by binding that function to this. That's actually built into arrow functions. They actually do bind on the fly. And I wanted to make sure I touched on this because this shows how seriously other developers are thinking about the problem of bind and the this scoping issue being counterintuitive. There was debate about actually changing the scoping of this in ES6, but the conclusion ultimately was that it was just too big of a BC break. It would just have been too large of an impact on JavaScript and existing code. But instead we get the arrow function, and I acknowledge that it's elegant, but I do want to point out that I still have to think about this, so to speak. I still have to ponder this, and I still have to handle this in the right way. And if I wanted to just use this method as my callback and not even bother to wrap it in some way, I would not have that option. That brings me up to ES 2015. Things are moving fast out there. ES 2015 does give us a super operator, a super keyword rather, and that is classy. That's nice. That lets us do what we've always had in Java or C++ or what have you. I can call the original version of the bark method. Doesn't alter the situation with scoping functional programming, but it does clean up. It allows us to have fewer cases where we have to fall back and peek back into the prototypal inheritance box. If I move on to ES 2016 classes even, and for this one I'll run it through Babel because even the latest node doesn't do this trick yet. There's another new keyword that I should acknowledge is pretty classy, and it's this double colon business. How many people have even seen this yet? Cool. Good. I'm glad I'm bringing something new today. So what the double colon does is it says it's a bind operator. It says the object dot method that you see next here, I want you to take that method, I want you to call bind on it and return a function that's been bound to that method. So we're now able to call setTimeout and hand it a pre-bound version of this method so that in 1 second that will run. And this is worth a run just for the fun of it. There, so we got our second bark there after 1 second. Hooray. Okay, so that's the state of the art in standards-based JavaScript types. And I wanted to show you those examples and acknowledge that a lot of this change was happening while we were developing our own solution for our own problems. We've been wrangling with these things since 2008. And so kind of evolving in parallel with all that. And so some of the things that we often do at Punk Avenue, you might ask, like, gee, was this worth it just to avoid this double colon? I actually think, yeah, kinda. But I admit that if this had existed more than, I don't know, 15 minutes ago, then perhaps we would not have discovered the same set of options. So let me show you an alternative pattern for object-oriented programming in JavaScript. Some people refer to this as the self pattern. And the basic idea of the self pattern is to say, if we're typing var that equals this in every method, why don't we just cut out the middleman and do that in the constructor and bind all and actually assign all of the methods to the object directly in the constructor. So what this does is this keyword is seen only once. It is only seen in the constructor. It is assigned to self, and then we forget that the word this exists. I literally never type this unless I'm creating a brand new type. Then I have self to play with, and the beauty of self, we've already talked about how that is scoped lexically, so that's always going to work, no matter whether we're writing asynchronous or synchronous code. So inheritance, following the self pattern, is also intuitive but different. I think that's the best way to phrase it, because it's not using the super keyword. I can't say that it's familiar. When I say it's intuitive, I mean that it becomes intuitive very quickly. In my constructor for Kali, for my subclass, this is the second and only additional usage of this, is that I do need to invoke call on my object and on the constructor for dog so that I can invoke it with the very same this. That's the one and only additional time that I have to mess around with this keyword. But now I have a Kali who has its very own closure, has its very own reference to self. And so I want to extend that bark method like I did before to do something in addition to the default version of bark. So I'm going to get to do it in an explicit programming style. I get to say very literally, okay, the old version of bark, hang on to that. All right, here's my new version of bark. And while I'm here, I'm going to invoke the old version. And if you're used to being bit on the hand by this all the time, you're probably reading this and it's like, you're just invoking a method. You're just invoking a method. Where's this? Where's this? You can't do that. Yeah, you can do that because this is lexically scoped and we're not using this and it can see self perfectly well. So it's going to do the right thing. One of the nicest things about this pattern is that asynchronous programming works with it. I mean, works in a natural and intuitive way. I can call set timeout in my bark after 1 second method, and I can just pass it self.bark directly. Because self.bark is inside a closure and already has a perfectly good reference to self, it's going to do the right thing 1 second from now. I don't need to think about binding it. I don't need to use any of the syntaxes for binding it. I just need to pass it. And I want to emphasize again that it's not just about asynchronous programming. It's also about functional programming, very much so, because I can call friends.forEach. And the first time I wrote this, just out of habit, I wrote function dog self.sniff dog. And then I looked at that and said, no, I don't even have to do that. I can just pass self.sniff to forEach. Things get elegant very fast when you follow this pattern. A lot of code goes away, a lot of difficulty goes away, and things get intuitive pretty rapidly. You also, and I'm not particularly advocating worrying that much about private methods or private properties of objects. How many people here have worked in Java or PHP or whatever, and you use the private keyword for something and you almost immediately had to make it public or protected? Sure, I mean, it comes up. Because what you're doing is you're going for separation of concerns and you're saying some of my properties, some of my methods are only for me. And it's a good goal to have. A lot of the time things migrate and they become more public. But still, you do get private for free, which you don't otherwise get in JavaScript at all, following this pattern. My bark function here is just a function inside the constructor. I can call it from inside that constructor, so from any method. I can't call it from anywhere else. It isn't visible anywhere else. So I've made it an implementation detail of bark after 1 second that's not exposed to the rest of the world, which can be a nice thing if you have some details which you know are going to change. I'm a big fan of great APIs to shitty code, by which I mean not that you should write shitty code, but rather that you should get your API right first. Because if your API is great, you have oodles of time to make your code more performant, safer, stronger over time. But people are going to actually use your code because the API is good. So The interesting thing about the self pattern is that I don't have to bring in any libraries at all. I mean, there's no extra code. There's no one behind the curtain here making that work. We wanted more than that. In creating Apostrophe, we had an interesting set of needs. We're in a situation where we're working with Node, so we're creating some long-lived objects that are responsible over a long period of time for doing a lot of things. And we're creating modules where people are extending and subclassing modules and types that are related to those modules. Let's say we have a type called a piece, which you would use for really any editable thing that isn't a page. And that's extended to make people, that's extended to make blog posts, and so on. And in working with that, there are types that are related to that. You might have a cursor, how many people have used MongoDB? Okay, so MongoDB has this idea of cursors. You call find and you don't get your data, you get a cursor. And then you can ask that cursor for the data. You can call toArray or what have you to get the actual data out. So we extended that idea. So there's a type of cursor for each type of piece and so on. So we have these related types, we have these parallel patterns of inheritance going on. And the self pattern is nice, but we wanted to be able to take that further and eliminate even more of the potential for mistakes. So we created an NPM library called Moog. And Moog wraps the self pattern and adds some additional functionality that we think is pretty cool. Moog, of course, is a famous brand of synthesizer. So when I want to work with Moog, the first thing I do is I require it, and then I'm going to invoke that little function it gives me back. It's going to give me back my very own synthesizer. So I'll use that to define types and create objects. And I'm going to define a type called dog. And I'm going to use the self pattern like you saw before to add methods to the dog. But I have this object here with a construct property. What's going on with that is it allows us to have more control over the process of constructing objects and to eliminate the boilerplate that you saw before. Even the small amount of boilerplate, there's no this, there's no var self equals this, there's no explicitly invoking the constructor of the parent class and so on. So when I look at a subclass, we start to see where that begins to pay off. I have a dog and I have a lazy dog. And the lazy dog extends the dog. But there is a challenge with this. When you follow the self pattern, you're going to be adding methods to the object inside the constructor. And now I want the dog to go right ahead and wake up. And the problem with that in this pattern, because it's imperative, is that when the lazy dog constructor starts up, it's going to override self.wake, but the constructor for the base class already ran. It's too late. Woke up has already been printed at this point. So to address that, we introduced an explicit distinction between construct and after construct. We're saying construct is the right place to capture information, to create methods, to get your object ready to use. After construct is the right place to invoke the things that have to happen after that object is created. And what that does is it allows us to flow through all of the constructors, replacing and building the constructors that we want. Oh, I left off a semicolon. I guess my coding standards are no good. Sorry about that. So my after construct is going to be invoked after all of those construct methods. And what this gives us is a really explicit pattern, a really explicit declaration of our intentions, and a chance to say that we believe in top-down programming, even though we're doing object-oriented programming, and even though we're working in JavaScript. It's not that common in JavaScript, except in really simple one-file programs, to see top-down programming because of the fact that functions are only... You can call plain old functions that are declarable, say function foo. You can declare that down at the bottom of a file, invoke it up at the top. And so you can do top-down programming and do these four things, and then the definition of those four, and then the things that those call. But once you start playing around with methods, at least in some patterns, it can be awkward to do. So by making this explicit, we bring that back. I also wanted to look at the difficulties that you get into with changing defaults in constructors. What we're after here is an ability to say, all right, we'd like to be able to create an object of a new subtype and say that, well, if it's a pretty dog, then its name is always prefixed with pretty. We want that option to already have been set before we get down to constructing the base class. And it's a common thing in subclassing to say, all right, some of the options that were up in the air in the parent class, they're locked down now. I know what they are. So you want to be able to modify that before the constructor for the parent runs. And if you're writing ES6 JavaScript, you can do that. You can modify things in your construct before you start invoking things. But here, we created a more explicit pattern by creating a before construct property. So again, this is something that Moog gives us where it makes this process very explicit and self-documenting and helps us understand how our objects are being scaffolded and brought into the world. Okay. So this is a moment. There we go. One more neat trick that Moog does that's worth mentioning here before I will show you some more like concrete examples from apostrophe. I think those are more interesting in a way, except you do need context, before jumping into that kind of thing. I wanted to show you that Moog also lets us have constructors that are asynchronous. That's a trick you normally wouldn't do with ES6 classes. So you might have, let's say, an init method that everybody agrees to call afterwards, and which takes a callback. But we wanted to make it so that we can decide that our parent class requires a callback in its after construct method, let's say, and then have a subclass that doesn't. Because we wanted to get away from the idea that I have to worry about how the parent class was implemented when writing a subclass. That there's a lot of value in that separation of concerns, in having that contract be something that I don't have to worry about. As long as I take the same arguments other than a callback, then this will just work. So I can construct my dog. I can decide that after my dog wakes up, it's going to check in with NASA, and it's going to observe what's going on in the latest NASA observations, which my dog does every day. And if your dog isn't doing on that, then they should really get on that. And then in my lazy dog, surprisingly, I'm still going to make those observations. I know that's a little surprising. But after that, I'm going to make sure I go back to sleep. And I don't have to have a callback here because synchronous code doesn't need one. So just for fun, I will run this demo also. That's if the internet. Oh, there we go. Bella looked at Lynn's Dark Nebula 1251. Good dog. Okay, so these are the things I can show you without showing you some nitty-gritty, without showing you a really functioning system. So I'd like to show you a little bit of what apostrophe does under the hood and how we really take advantage of these patterns, and how Moog helps us do that a little bit more effectively. So I'm going to pop into an actual project here. This is app.js, and this is where every apostrophe site, every apostrophe project begins. It's in an app.js file where you're going to configure apostrophe and decide to load some modules. Every module gets loaded by Moog for you. We have an additional module called Moog require, which goes out to NPM or to bundles that you've provided, finds those things, defines them as Moog types, configures them for you. So we're taking advantage of that here. All this configuration that I'm passing in actually is another feature of Moog I didn't mention yet. Any properties that aren't construct or before construct, after construct, those actually become properties of that options object that's passed when it's constructed, which makes it very, very easy to say, okay, as I'm configuring here, as I'm extending at the project level, I'm just going to change a few properties going in. So wanted to show you our database module a little bit, not the gory details, but just the fact that in after construct here, I'm going to do a little top-down programming that's readable so that you can see what it is that this module actually does as it starts up. It's going to connect to MongoDB, and it's going to invoke this early reset task. And after it's done the asynchronous stuff, it's going to invoke a keep alive method. And you'll notice that in calling async.series, how many people have used async.series before? Okay, async.series is closely related to promises in that they're both solutions to the problems of asynchronous programming. They keep that from getting hairy on you. And I would certainly recommend using promises in a lot of cases, but you would still benefit from this approach in combination with promises. And one of the nice things here is async.series lets me pass an array of functions that I want called in that order, and I'm able to just pass these methods of the module. I don't have to wrap these and bind these and do jumping jacks in order to get that to cooperate. Just to show a little bit more of how it supports top-down programming in object-oriented JavaScript, this is the doc type manager module. I mentioned that in apostrophe, a content type like, say, a person or a user or what have you is something referred to as a piece. Those in turn are all docs, just like a page is a doc, anything in our Mongo collection. And so all of those have a doc type manager. That would be an object that's responsible for working with them. And in configuring those, I'm taking advantage of that ability to pass options just by doing configuration that I mentioned. But also, in my after construct, I'm able to do, again, some top-down programming and just say, I want to invoke these methods once they're ready. But this enables me to say, these methods are going to get called only after all of the subclasses of this module have all also been initialized. Their constructs have been called. They've had a chance to patch and replace all of these methods and get things to the place that they want to be. And I can also use before construct here to make decisions about some of the options, such as apostrophe has this notion of schemas, and I know you've all used databases that involve schemas or other systems that involve schemas. It's just a really pain-free way to quickly create new content types and populate them with fields. Apostrophe tries to take that farther by saying we're going to use those schemas on the browser side also. So if you create a schema, you automatically get a user interface to go with that. And we then carry that through to everywhere if you're working with content on a page or content in a piece or what have you. Another trick that we get here that is awkward with the regular class syntax is that if one of our classes is large, we can break that code up for readability. There's nothing to prevent us from using require right here in the middle of the construct property. So I can pull in browser.js and add all of my browser-related methods here. One more feature that it's a little bit brain-hurty maybe, but worth mentioning because for us it's really one of the killer features of Moog at the end of the day, is that we also have content types on the browser side of things. When I'm working with apostrophe and I want to, let's say, work with users, I need to be able to fire up this modal and edit a user. So there has to be browser-side code that corresponds to this user type. Did I write any code explicitly for users? Maybe. Did I extend that class? Did I add additional methods just for that one? Geez, I don't even know. Sometimes I don't need to. I'm just configuring schemas and things are really simple. So do I have to have boilerplate code that creates a user class, whether I actually need to do anything custom in there or not? I don't. And the reason why I don't have to do that is because we have, with Moog, this concept of mirroring. We can ask Moog, we can say, here's all the metadata about this class, about this type, about this module. I want you to define a new type which has exactly the same series of parent types, exactly the same inheritance tree, but with, let's say, -editor attached at the end of all of those. And if it already exists, great. If not, please define that so that those spaces, those gaps in the inheritance tree are always filled in. What this gives us is rapid application development. For about 2 seconds, it's strange. It's not familiar, it's true, that these types are already there for you. And then after those 2 seconds, it's extremely intuitive. You subclassed pieces, so of course you get an editor modal for pieces. And of course you don't have to worry about what you're supposed to be extending if you decide to add more functionality to that. Why would you have to? Well, only because everything else requires you to. So just to move that along a little bit, I know where we are on time. Just to show you, on the browser side, there's a type that corresponds to the doc-type manager module on the server side. So we're using Moog in both places, both in the browser and on the server. On the server, Moog is using require to just automatically pull things in. On the browser side, since we're pushing JavaScript files to the browser, we call apos.define to define our types ourselves. But we are taking advantage of that mirroring feature. So this type that provides some click handlers for opening up those editor modals and so on for any given type of piece, this will automatically get subclassed. And if I don't need to extend it explicitly, I don't have to. If I don't need to change any behavior, I just get that whole tree of inheritance for free. That editor modal, for instance, that I mentioned, this is defining the base type for it. But if I don't need to change anything other than, hey, here's a schema, run me up a modal, then I don't have to. Just to look at one more cool Moog and apostrophe feature. Let's say that I've got many different types of pages on the site, and we do here. We have, people pages and so on. We have ordinary pages, but I want on all kinds of pages, I want to be able to have one extra field. In order to do that, I'm going to provide a new definition for apostrophe custom pages. This is the standard module in apostrophe that powers all regular pages in the page tree. And you can find that in node modules apostrophe. You can find that in our NPM module. But if you also provide it at project level, if you provide another definition, of course, you'd be forgiven for thinking, well, you just wiped out your standard definition of it. But Moog doesn't do that by default. What Moog does by default is it says, oh, OK, you're defining this again. What I think you want, has anyone used Objective-C's categories feature ever? OK. One person, all right. What categories do in Objective-C, so this is an official Apple-blessed thing that I cannot be criticized for doing, no, just kidding, is they let you say, all right, here's NS string, here's this type for working with strings. All NS strings should now have an extra method, and that will just work throughout my application. That's a cool thing that you can do in Objective-C. I haven't seen it in very many other programming languages. To give JavaScript its due, in plain old prototypal JavaScript, you can do it by modifying the prototype object. But that's not something that the ES6 syntax is really encouraging you to do. So in Moog, if you define the same type twice and you don't explicitly say you want to redefine it, what happens is you extend it with additional code, and it automatically replaces the old version with yours, so that everybody else sees your modified version of it. So what we've done is we've introduced this extra field, this extra dropdown, for every page type in the whole project. So when you talk about don't repeat yourself in apostrophe, you're talking really serious amounts of DRY in that you're able to modify behavior at any level in that inheritance tree and have it apply to everyone. And yet you never have to copy and paste code. You're never stuck because the code didn't accommodate the idea of being extended in that particular way. I wanted to touch on just a little bit more functional programming. I've already talked about using for each and so on, and those count, but you'll all recognize these Lodash functions. If you're Lodash or underscore fans, how many people here use Lodash or underscore regularly? More of you should use underscore and Lodash regularly. They are wonderful things, and they free you from thinking about dumb stuff, and they let you just write code. In particular, they let you say things like, I'm going to partially apply a function. In English, that means I want to take this function, this method, I want to take these two arguments, and I want to create a new function that always passes these two things. And then it passes anything else I want to give to it. And what this is giving me is that in calling async.series, which just expects functions to take one callback, I can say, actually, I want you to invoke this guy with these two arguments and then the callback. So this gives me back an almost, this looks an awful lot like ordinary linear synchronous programming, very, very close to it. And yet we're using object-oriented programming in a really uncompromised way. So there's a bunch of wins here. There's wins all over the place. So why isn't this more common? Well, there is a catch. And the catch is that there are some performance implications. And I said before that I don't worship performance as a god, but you do have to respect it as an issue. So I wanted to show you a few numbers. First for what happens at a totally unfair benchmark, but by unfair in this case I mean totally unfair to me. Let's see. There we go. There we go. So this, I won't go through the agonizing details, but if any of you have ever written a game, you probably recognize what's going on. I've got a sprite type, the meaning to represent one object on the screen. And that's got a little bit of logic to move it around and to keep it in bounds. And I've got an alien type that extends the sprite so that it goes after the player because they're mean like that. And I've got a player type that just sort of hangs around and is hapless and waits to be destroyed, as we usually do. Then I'm going to create 1,000 aliens, and I'm going to run through 60 ticks of moving them. And 60 is significant because that would be 60 frames per second in our game. I've got that implemented here using the self pattern. But I also have it down here implemented just the same, but with the prototypal inheritance pattern. So I like to think of this as a reasonably unfair test in that there's no functional programming here. So none of my wins are really coming into play. But what we are going to see is what the price of my approach is. OK, so it turns out that the self pattern takes roughly twice as long. And I know these are small numbers, but I ran this many times and got similar results. It takes roughly twice as long to construct the object in the beginning. And it takes roughly twice as long to go through all those iterations of moving them around, which there's a constant factor there. But yeah, it's a performance hit. You pay a price for it. However, just to put this in perspective, we're moving 1,000 objects. And in order to be at 60 frames per second, we need to keep this number, the number of milliseconds, under 1,000. 17 is a long way under 1,000. Even on mobile, we don't have much trouble hitting 60 frames per second with code like this. Also, we're constructing a lot of objects, moving a lot of objects around, which in many applications isn't the case. You're working with user interface code. You may have on the order of 100 objects in play. And so these impacts just aren't on the same level. And finally, it's worth keeping in mind that when you're doing any kind of asynchronous programming, whenever you're waiting for things to happen or timing out, or just literally waiting on a database to do something, the amount of time you spend bound by the grunt power, the raw horsepower of JavaScript code is extremely minimal. And in fact, these are not the only performance issues. So I'm also going to show you a metric that is a little bit more fair. And this metric brings us back to the dogs and the sniffing. And we're going to do a lot of sniffing so that we can measure the time involved in doing that. But we're going to implement it 3 ways. We're going to implement the dog sniffing test, the famous dog sniffing test that you're all familiar with. We're going to implement it with arrow functions, which means calling bind. But it is a nice syntax for calling bind. But just keep in mind, it's the same thing if you haven't used arrow functions yet. We're going to implement it with the var that equals this pattern in this one individual method. And we're going to implement it with the self pattern, where var self is up here in the constructor. Otherwise, it's the same code. We're going to loop through. We're going to sniff 100,000 friendly dogs. And we're going to build a string, and we're actually going to print the length of the string at the end, because I don't want V8 to be so smart that it optimizes and says, oh, this code doesn't do anything, which it'll do to you if you're writing performance tests. You have to be very careful of that. Oh, and I have to do that with expose GC so that I can deliberately garbage collect in order to see what's going on with RAM. OK, here we go. So with the arrow function test, we start out with this much RAM already used, just as overhead. With 100,000 sniffs with the arrow test, it takes about 82 milliseconds. With the that pattern, it drops to 37 milliseconds. The that pattern is about twice as fast, more than twice as fast perhaps, as working with bind. So it's really worth keeping in mind that bind can be, if performance is really your thing, that's cool. But then be consistent. Don't use bind. Use a closure, at least in that particular method. And finally, the self pattern is very close to the speed of the that pattern. The difference, I think, comes from the fact that the closure is a little bit larger, and the fact that there's more overhead, involved in constructing and calling things. But it is still much faster than using bind for the purpose. So as soon as you want to do functional or async programming, there actually is a performance win over time in using the self pattern, or at least the that pattern in your code. Finally, I wanted to acknowledge the impact on RAM. It does take more RAM if you use, it uses the least RAM if you use the that pattern. That makes some sense because bind has a little overhead of its own. But it does take more RAM if you use the self pattern for your code. At the same time, though, I want to put that in perspective. It takes 500 bytes per dog. I used to work on computers where I had 4 kilobytes, and that was exciting. I currently have a computer that has 8 gigabytes, which is difficult to even say, let alone believe. I think that I can afford 500 bytes per dog if it means that I'm going to have fewer bugs in my code. So that's it. That's my essential thesis. That's where we've been at the last few years in our approach to object-oriented functional programming in JavaScript. I know some of the ideas might be, a little off the beaten path or a little controversial, so I decided to embrace that, get some performance tests in there. But nevertheless, I look forward to being harangued. I look forward to, hearing your perspectives on this stuff. Please grab me over lunch and tell me how I'm wrong. I'm fascinated. Thank you very much for your time. I really appreciate it. Oh, sorry. Do I have a moment or two for questions? 11:55, cutting it close.
Yeah, I think if people do have questions, they can ask them, but it is lunchtime. So,
Yep, okay.
So actually, if I can steal the mic. So lunch is back and out to the right, and the bathrooms are just behind the food. So that's where you want to go, and come on back in, and if you have questions, go for it.
Okay. Any questions? Yes?
The code samples, will they be available on GitHub?
Oh, yes, the code samples are available, and they're available at this URL here. Anyone else?
With the constructor self pattern, is it more expensive because it's creating those functions for every single object? It's like the functions.
That is part of it, yes. Interestingly, at runtime, there's a little bit of a cost too, I guess because the prototypal chain is very well optimized.
So if you did have something where you were iterating over a large collection, for example, and
right.
Creating a lot of objects, you could just fall back to the prototype way of doing it.
You could do it.
In one case, right?
You could do it. And something else you could do that is my preferred solution to that, I just didn't have time to get into it, is use the flyweight pattern. Because I think it's more explicit. I like the idea of saying, here's a smart object that manages all the users. And the individual users just be dumb JSON objects. And so you have methods of that smart object that you would pass a user to in order to make him jump. Yeah. Cool. Anyone else? All right. Enjoy your lunch.